Okay, this video picks up where the last one left off. So let's look at the next setting. I want a square wave with a different frequency, a +1, and it's 3 volts peak. 23k hertz plus 1 offset. So that's what I'm given. I'm given a voltage, frequency, and an offset, yes or no. And I think I put in an offset even if I made it 0. So I think I can remember 3 things. If you do a spreadsheet like this to keep track of things and you change the frequency, you have changed everything over here on the far left. If you change the voltage, you change some stuff in the voltage column. But if you change the frequency, all this has to be revisited. If you do it as formulas, a lot of it will go automatically. If you don't do it as formulas, then you have to make sure every term is correct. If you don't, and you go into Spice and you put in this, you will not get the results you hope for. So I'm going to say 19. I want to do a 19. K hertz, 19,000. Notice that I did not, well, it did round. Let's make it something less. Let's make it 17,000. There we go. Okay, so there's my period. It did the calculation. Comes out to be 0.0006. Let's go back to a general format. Let's see, format cells. Let's just click back on general for number and click OK. Okay, so I'm really 5.88 times 10 to the minus 5. So that's 0.0005. If I round that, which would be convenient to do, this would become 0.0006. So I've got to move my decimal 1, 2, 3, 4, 5 times. So I need a 4th 0 and a 6 here. So that's one change if I round it. And now I need to go back and format cells and get them into that. Let's do about 8. I really hate to do a lot of decimal numbers though. I can make everything scientific. Let's do that, and 9 decimal places. Let's just do that, okay. That should work. That really makes that bad, but that's okay. I can make the column a little wider. Everything's happy now. Okay, so there is my raw period based on frequency. It's 1/. I'm going to round it to something convenient. My sample time is going to be add a 0. So it's 1, 2, 3, 4, 6. So my sample time needs to have 5 zeros and a 6. It needs to be 1/10. You can do this automatically by taking a 4 and dividing it by 10. So you can make sample time automatic. Just take your rounded number, divide it by 10, or you can manually add an extra 0. So I went from 4 zeros, 6 to 5 zeros and a 6. My delay time is 2 waveforms. So we calculate, we typed that in manually last time. I can come up with it. What is 2 times my rounded? So I can come up with this one manually, or I can just take the 6 and double it in 12. So that'd be 3 zeros, 1, 2. Either way, I get my delay time. So I'm going to do that. I'm going to take A4 and I'm going to multiply it times 2 equals A4 times 2. This gives me 2 waveforms to let anything settle out that needs to settle out when the circuit starts up. Okay. Still want 3 waveforms. Let's change that. Let's say I want to look at 4 waveforms. Just so we can make sure we check everything, because you got to check everything when you start it. My start time is the same as my delay time, and my end time will be 4 waveforms at this, which is 0.00024. Add them together, my end time is automatic. For my voltage, let's say I'm doing square. Let's say somebody gives me a 4 volt peak square wave, so that'd be 8 volts peak to peak. And what we did in here is I did the 0.71. Well, that only works for a sine wave. My peak is my RMS for a square. So you can have a column for a sine, a column for a triangle, and a column for a square if you want to, or you can just realize, hey, I'm doing a square wave this time. That's good. Let's go with a +1 offset, just so we have changed that. So I'm feeling a little bit confident about this. Now with a square wave, I have to know what my on time and off time is. Okay, so there is a rise time, a fall time, and a time on. And I think it asks for duty cycle. We will see in a minute. Your duty cycle is your whole period. Okay, if you want a symmetrical waveform, your time on has to be half of your duty cycle. But with a square wave, you also have to go in and put in a fixed rise and fall time. So I'm going to say rise time and fall time. And basically what we're doing is we're going to build this square wave. So let's look at this. So my duty cycle, or my entire time, is this 0.000, 4 O's and a 6. 1, 2, 3, 4, 6. And of course it's going to change it. So let's go in there and format those cells so we can see it in time. And 6 decimal places is good. Alright. Rise time and fall time, what I typically do for a square wave is I take a very, very small fraction of this. So 1, 2, 3, 4, 5, 6. I might not have enough decimal places. So let's go ahead and make that 7 decimal places. Yes. Okay. So if my total cycle is this, my rise time, I want it to be all these zeros, 1, 2, 3, 4, 5, 6 zeros and a 1. Point. 1, 2, 3, 4, 5, 6, 1. My fall time has to be the same, because you want your waveform to be symmetrical, so your rise time and fall time should be the same. So 0.1, 2, 3, 4, 5, 6, 1. Okay. I have just subtracted 2 from 600, so I'm 598, right? 600 minus 2 is 598. And if you divide that by 2, you get 399. So my time on is 0.0000399. So 399 plus 1 is 400. Excuse me, 299. There we go. 299 plus 1 is 300, which is half the 600, which is my total duty cycle. And then my rise time is the other fraction. So my time off will wind up being 299 as well. So my time on and my time off by default will be the same. Okay, so we got all that. Now let's move over to LTSpice. I'm using the same circuit as last time. I'm going to close my sine wave graph because we're going to go in and we're going to make some changes. I'll make this bigger so you can see it. Okay. My transient analysis is going to change because my frequency changed. My sine has to change because my waveform has changed. My resistor will stay the same. So let's get the voltage source right to start with. Basically what's happening when you do a square wave or a triangle wave, you have to use pulse. And when you use the pulse, it changes what is down here. You have your initial voltage, your value of your voltage when it's on, your time delay, your rise time, your fall time, your time off, and your time on, and your total period time. And then your number of cycles if you want it. So these numbers are coming from the last thing I entered because I just changed it. So I'm going to just blank them all out and we'll go through them one by one and see what we get here. Okay. What is my initial voltage? Well, I've got a 1 volt offset positive and a peak voltage of 4. So my initial voltage, we're going to say, is the low end. So I've got a 1 volt offset and I'm trying to get 8 volts peak to peak. So I'm actually going to be -3. Is that right? No, it's going to be +1. We're going to wind up building this. We're going to wind up building this with the peak to peak values. Okay, so if I'm 8 volts and I'm shifted 1, I'm going between +5 and -3. So my initial is -3, which is the -4 plus 1 offset. My on voltage will wind up being 5. My time delay, I'm going to leave that alone. I want it to start immediately. My rise time, we figured it. 1, 2, 3, 4, 5, 6. 6 zeros and a 1. Point. 1, 2, 3, 4, 5, 6, 1. And you can put these in with engineering prefixes if you want to. Whoops, I put that in the wrong place. Point. 1, 2, 3, 4, 5, 6, 1. I'm not having any delay. Okay, my rise time and my fall time should be equal for a square wave. My time on is 4 zeros and 299. And my total period is my duty cycle, the 0.406. And number of cycles, I think we're doing 4 with a 2 delay, so let's do 6 or 7. So now I'm going to click OK. And it changed this to the values I wanted. It just added them up. It does it automatically. Now I got to go in and do the analysis and change the analysis. So I'm going to go in and edit my simulation command. Well, we figured start time, stop time. See, that's actually the easy part. My stop time is 3 zeros, 3, 6. 1, 2, 3, 3, 6. My time to start saving data was 3 zeros, 1, 2. So whoops. Cancel that. Click over here, backspace, 0, 1, 2. And my time per step, or my sample time, is 1, 2, 3, 4, 5. 5 zeros and a 6. Is that right? 1, 2, 3, 4, 5 zeros and a 6. Okay. So, if you go to square wave, You got to know rise and fall time, time on duty cycle. Triangle is going to be the same thing, except your rise and fall time are going to get longer, and your time on will get shorter. So if you think about your square wave, you got a long time on, and when you go to a triangle, your rise and fall time are longer, but your time on is very short. And I might do a video to illustrate that. We will see. So have I simulated? I think I hit run. There's my run, and there is my 4 waveforms. And it's going from +5 to -3. So I've got a 1 volt offset, 8 volt peak to peak, 4 volt peak, square wave. And thank you for watching.